The mic off. Yeah. Those are online are together.
Yes, sir.
Yes, sir.
So I think this was the last concept discussion. So the points we were discussing is what is the resultant intensity when two light waves which are traveling the same direction interfere with each other. So what is going to be the value I1 plus I2 plus 2 root of I1 into I2 multiplied with cos phi, where phi is going to be the phase difference between the first and the second. Right. Now we saw for intensity to be maximum, the value of phi is supposed to be equal to 2n pi, and for the intensity to be minimum, the value of phi is supposed to be 2n plus 1 into pi or 2n minus 1 into pi. So if this kind of a phase difference occurs, then both the waves will interfere to generate a dark point. Right, that's what is called as destructive. No? Whereas if they form like this, then it will produce a bright spot. Right? So for bright spot to be produced, it is 2n pi, and for dark spot, it is 2n plus 1 into pi or 2n minus 1 into pi. Right? The next concept is called as path difference. So next concept is called as path difference. So what is path difference? Observe. Suppose I have a wavelength where I can take the x-axis to be either in terms of angle or either in terms of wavelength or in terms of time. Okay. So if suppose I take it in the case in terms of angle, then this angle will be 0. If this is pi by 2, this will be pi, 3 pi by 2 and 2 pi. Means by the time wave has completed 2 pi radians, right? Where the phase difference between the point O, and let me call this point as P. So if the phase difference between point O and point P is 2 pi. Okay. If the phase difference is 2 pi, then what would be the corresponding difference, which is called as path difference? Means how much distance is the wave supposed to travel to complete one revolution? Or how much distance the wave is supposed to travel to complete 2 pi radians? It is basically one wavelength. First, if I measure the distance from here to here, this is the length of the wave. So 2 pi radians corresponds to the phase difference, and the corresponding phase difference for 2 pi, corresponding path difference for a phase difference of 2 pi will be equal to lambda. Right? In a similar way, if I take 2 points A and B, if I take 2 points A and B, and if I draw two perpendiculars, if I say the angle here is theta 1 and theta 2, then what is going to be the phase difference between them? So, if the phase difference between them, if I call it as delta theta, which is equal to theta 2 minus theta 1, right? So, for a corresponding phase difference of delta theta, what is going to be the corresponding path difference? So, that's what we need to find. Okay. So, what we can do is, instead of taking this, so I took it only for the sake of understanding that if I take two different points, because the previous scenario when I wrote 2 pi, I took the extreme points. In order for you to understand what phase difference between 2 points means, I took two random points A and B and the corresponding phases of them. So what we are going to do with this particular expression is, I'll just do a small modification. Instead of calling it as delta theta, if I call it as delta phase, means I'll come from the beginning. See, if the wave has a phase difference of 2 pi radians, the corresponding path difference it has is lambda. Now, if the phase difference is given as delta phi, and if I call the corresponding path difference as delta p, okay, phi is used for phase and p is used for path difference, then by using unitary method, what I'll get is delta p will be equal to phi divided by 2 pi into lambda. So delta p will be equal to phi divided by 2 pi multiplied with lambda. Is that clear? So this is going to be another important expression to be remembered. The point why we discussed here is, not every time you will have delta phi. Okay. Not every time you are going to have the phase difference available in your hand. Sometimes you will have to find the difference in terms of path. So at that point, you need to know what should be the corresponding path difference for constructive and destructive interference. Right? First, I'll complete this and you can make a note. So we saw that for constructive interference, delta phi should be how much? The phase difference is supposed to be equal to 2n pi. Then what would be the corresponding path difference? Delta p will be equal to, if I substitute 2n pi here, I get 2n pi divided by 2 pi multiplied with lambda. 2 pi and 2 pi will get cancelled. So delta p will be equal to n lambda. Means for the same constructive interference, C stands for constructive interference. For the same constructive interference, if the phase difference is given as 2n pi, then the corresponding path difference is given as n times lambda. Okay. So this is a point to be noted. In a similar way, if I want destructive interference, then I know delta phi should be equal to 2n plus 1 into pi or 2n minus 1 into pi. Right? Now, if I take this value and plug it here, then I'll get 2n plus 1 into pi divided by 2 pi into lambda, or 2n minus 1 into pi divided by 2 pi into lambda. So pi. So pi and pi will get cancelled. Similarly, here also pi and pi will get cancelled. So delta p will be equal to 2n plus 1 into lambda by 2 or 2n minus 1 into lambda divided by 2. So this is going to be the corresponding path difference taking place for destructive interference. I hope it is clear. right? So let's proceed. Now, the summary is going to be, when you talk about interference of two light waves, right? Then for constructive interference, the phase difference is supposed to be 2n pi, where n belongs to z, and the corresponding path difference is supposed to be n times lambda, and here also n belongs to z. Similarly, for destructive interference, the phase difference is supposed to be 2n plus 1 into pi by 2, or 2n minus 1 into pi by 2. And sorry. Similarly, for destructive interference, delta phi should be equal to 2n plus 1 into pi, or 2n minus 1 into pi. The corresponding path difference will be equal to 2n plus 1 into lambda by 2, or 2n minus 1 into lambda by 2, where n belongs to. So as I mentioned previously, these expressions are very, very, very important for us to solve the problems, the rest of the problem. Right? The next concept that we are going to discuss is Young's double slit experiment. It's called as Young's double slit experiment, or you also call it as YDSE. Suppose I have two slits, okay, through which light is passing. And if there is a screen,
Sir,
yeah, tell me.
sir, your voice is not audible, sir.
Now is it audible?
Yes, sir, it's better.
So, let's say there are two slits, which I call as S1 and S2, okay, through which light is passed. Okay. So generally what happens is, when you have the plane wavefronts coming, okay, these are the plane wavefronts, right? So when these plane wavefronts are coming, as soon as they hit this slit, right, they start getting converted into spherical wavefronts like this. And here also you will have set of spherical wavefronts going like this. Okay. Now what will happen is, these spherical wavefronts which are traveling in this medium, right, between the slits and this part called as the screen, right, when they start traveling in the same direction, you will start observing a pattern on the screen. And how will that pattern look like? You will have a pattern which is a bright spot, and you have a dark spot. Again, you have a bright spot, and you have a dark spot, and you have a bright spot. So it keeps on going like this. You have an alternate pattern of bright and dark spots continuously placed in the upward direction as well as in the downward direction. And why is it happening? It is purely because of the concept of interference. So the difference is, when we discuss the concept of interference of light, we were discussing only the theoretical part. we took one of the waves as y1 is equal to a1 sine omega t and the other as y2 is equal to a2 sine omega t plus pi, and then we tried to derive an expression for constructive and destructive interference. But this Young's double slit experiment is actually a practical application of interference. Means you can actually see this. Right. If you can see this kind of a pattern which is happening due to a phenomenon called as interference, now we will use the conditions that we have derived in the case of phase difference and path difference in this to find out the distances between the bright spots and the distances between the dark spots. In a similar way, if you want the distances between the bright or dark spots to be increased or decreased, what kind of adjustments you need to do in the experimental apparatus? So these kind of calculations are what we are going to see in this particular topic. So I hope you are able to understand why YDSC is an application of interference of light. So interference is just a theoretical concept. YDSC is actually an application. Okay. So if I look at this diagram, then it is going to be something like this. If I have two slits S1 and S2, and I have a screen here, right? So these wavefronts are there. We know the concept that rays are perpendicular to these wavefronts. So what I will do is, I'll consider one of the rays from slit S1 and I'll consider another ray from the slit S2. I will say that these two rays are going and falling at some point P on the screen. Okay. So that point P, I don't know whether it is going to be a bright spot or a dark spot. I have no clue about it. Only thing is I'm considering a random point. And then we will start the derivation by trying to understand what will happen if it was a bright spot and what will happen if it was a dark spot. So it looks something like this. So this is one ray and this is another ray, and they both are going and falling on the screen, let's say at point P. Okay. I just want to this is one and this is another ray. So if you observe, S1P is traveling a certain distance and S2P is also traveling a certain distance. Now the question is, are they both traveling the same distance? The answer is obviously a no, right? So if you see among both, which ray is taking a greater distance according to our assumption? It is obviously the ray from S2. So if I am able to calculate the distance S2P and subtract the distance S1P, I will get a value called as path difference, because I am calculating the difference in the path lengths traveled by individual rays. Right? And these are all the experimental measurements that we are going to take. So the distance between both the slits, we will take it as small d. So the distance between the slits is taken as small d, and the distance from the slit to the screen is taken as capital D. Okay. Now, if I take the midpoint of these two openings as, let's say, O for instance. Right. From here, if I drop a perpendicular, I'll call this point as O dash. So the projection of O on the screen, I'll call it as O dash. So from this O dash, let's say this distance is Y. So this distance is Y. Okay. Now we need to use some simple geometry to derive what is going to be the value of Y in terms of small d, capital D, and the path difference. We'll try to do it. Okay. We'll try to take all the values and solve. Suppose I drop a perpendicular from S1 onto the ray traveling from S2. Okay. Then I get this extra distance. This extra distance is what is called as path difference. So if I take it as M, then this distance is what is called as the path difference. So this path difference is what I'm going to calculate. So to put it in simple terms, I'm only going to do S2P minus S1P. I want you all to concentrate. Okay. For which I'm doing a small construction. If I take this point to be A, and from here I'm dropping a perpendicular again, I'll call this point as B. Now, since I'm dealing with distances, what I do is I look for right angle triangles. Okay. So if I look at the triangle PAS1, okay, if I take the triangle PAS1, it forms a right angle triangle, then I'll get S1P square is equal to S1A square plus AP square. Right? So hypotenuse square is equal to S1A square plus AP square. Okay. Similarly, if I take the triangle PBS2, PBS2, if I take this triangle, then I'll get S2P square. I'll get S2P square is equal to S2B square plus BP square. Right? Here, an important point to be noted is, if I want to calculate S2P minus S1P, first I need to calculate S2P square minus S1P square. So that I can write this as A minus B into A plus B. So S2P square minus S1P square will be equal to S2B square plus BP square minus S1A square plus AP square. Right? S2B square plus BP square minus a bracket S1A square plus AP square. Right? But here, if you observe, S1A and S2B are the same. They both are equal to capital D. So S2B square and S1A square will get cancelled. So what is that you're left out with? You're left out with BP square minus AP square. Right? But what is BP? So if you see this distance B to P, from O dash to P, this distance is Y. Since I took O to be the midpoint of both these slits, then this particular distance will be D by 2 and this particular distance will be D by 2. So to put it simpler, this is D by 2 and this is D by 2. Had that been the scenario, then what should have been the value of BP? BP would have been D by 2 plus Y. So it is basically Y plus D by 2. So Y plus D by 2 the whole square minus, what would AP mean? So Y minus D by 2. I'll do that. I'm dealing with the right hand side. So BP square minus AP square. So I'm dealing with the right hand side. Left hand side I have not yet dealt. So if I observe the right hand side, A plus B the whole square minus A minus B the whole square is 4AB. Okay. So Y plus D by 2 the whole square minus Y minus D by 2 the whole square. So A plus B the whole square minus A minus B the whole square is 4 times AB. So 4 into Y into D by 2 will give me 2Y into D. Okay. So this is going to give me 2Y into D. But remember the fact that you arrived at this 2ID starting from here, S2P square minus S1P square. So copy it to this. Now what we'll do is, on the left hand side we have S2P square minus S1P square. On the right hand side we have 2 into Y into D. Right? You have 2 into Y into D. So the S2P square minus S1P square, we'll write it as S2P minus S1P into S2P plus S1P is equal to 2 into Y into D. Okay. So this S2P minus S1P is called as the path difference into. Observe what I'm going to do now. This S1P and S2P, according to the experimental setup, are considered approximately equal to T itself. I repeat it. Listen to this carefully. You will be able to observe the interference pattern only when the path difference is a multiple of lambda. So lambda is wavelength of whom? Lambda is the wavelength of light. So if you see the wavelength of light, it is generally in terms of few nanometer or angstrom. Right? When that is going to be the scenario, since this delta P is going to be a very small quantity, what we can assume is this S1P and S2P are almost close to 0.4. So that this S1P and S2P are approximately equal to T. But this thing we will not do it in the case of S2P minus S1P. We will apply it only in the case of S2P plus S1P. Okay. So here, what we will do is S2P is approximated to S1P is approximated to capital D itself. What is capital D? Capital D is the distance between the slit and the screen. Okay. When you do this, you will get 2 into capital D here, which will be equal to 2y into small d. So what is going to be the path difference? Delta P, here 2 and 2 will get cancelled. Delta P will be equal to y into small d divided by capital D. Right? This is going to be the path difference. And we know that for constructive difference, path difference will be equal to n lambda, which means y into small d divided by capital D should be equal to n lambda. So from this, what can I say? Y will be equal to n lambda into capital T divided by small t, and this value can be written as y with a subscript n. So the meaning of this is, as I keep substituting different values of integers in the place of n, I get different values of y. Okay, those different values of y's are the distance from the center where you have every bright spot present. Because what is the interference I spoke about? It is the constructive interference, right? So if you look at the screen from the point O dash at a distance of wherever you substitute the value of n as 1, 2, 3, right? For example, if I substitute n is equal to 1, I'll get lambda into capital T divided by small t. Means from the center, right, you will be able to find a bright spot at the distance of lambda into capital T by t. And from this bright spot, where will you find the next bright spot? At the same distance, lambda into capital T by t. The distance will be lambda into capital T by t, but the points coordinate will be 2 into lambda into capital T by t. Similarly, if you substitute 3, you will get 3 into lambda into capital T divided by small t. The same thing happens when you start substituting -1, -2, -3. The same thing happens in the downward direction. Means this bright spot will have a symmetric bright spot at the bottom also. Okay, so it will be minus lambda into capital T by t, minus 2 lambda into capital T by t. It keeps on going like this. Keeps on going. And here an important point to be noted is, I told you what happens when you substitute the value of n as 1, 2, 3 or -1, -2, -3. But what happens when you substitute a 0? So when you substitute 0, this y will also be 0. Means at the center, at the point O dash, it will be a bright spot. Okay, it will be a bright spot, because when we say about constructive interference, what should be the path difference? It should be n lambda, where n can start from 0 also. Means if the path difference is 0 also, you have a constructive interference taking place. This is an important point I want you to remember, right? And why is this point having a bright spot? It is because from S1P and S2P, if you see the diagram, right? If you see this diagram, from S1, this point O dash, and from S2, the point O dash is at the same distance. Means if you look at the diagram format, it will be this way, right? When you see it, it will be in this way, such that this distance and this distance are the same. So path difference is 0. So point to be noted, the central spot is always a bright spot. Okay. Apart from that, we will take the other relative bright spots in addition to it. Okay. So the dark spots between two bright spots, no?
So in dark spots, the range will be more than.
We'll see. We didn't do the destructive interference. If we do that, you will understand. Similarly, for destructive interference, what is supposed to be the path difference? Delta P should be equal to 2n plus 1 into lambda by 2, or 2n minus 1 into lambda by 2, accepted. But what is delta P? Y into small t divided by capital T. Y into small t divided by capital T is equal to 2n plus 1 into lambda by 2. Means what is going to be the value of y? The value of y will be equal to 2n plus 1 into lambda into capital T divided by 2 times small t. Right? So this I will get when I use 2n plus 1 into lambda by 2. Right? So this value we will get when we use 2n plus 1 into lambda by 2. Let me complete it. Similarly, if I use 2n minus 1 into lambda by 2. So when I use 2n plus 1 into lambda by 2, what is the value of y I got? This is the value. 2n plus 1 into lambda into capital T divided by 2 times small t. Similarly, if I use delta P is equal to 2n minus 1 into lambda by 2, what will I get? Here it is y into small t divided by capital T, which is 2n minus 1 into lambda by 2. So y will be equal to 2n minus 1 into lambda into capital T divided by 2. Right? Now, if you observe, For constructive interference, our life was easy. It was only one expression. Whereas when you talk about destructive interference, right, we are having two terms here. Right, this is the tricky part. And what does the value of n take? So I want everybody to concentrate. This is a very, very, very tricky part. So when you're solving the problems, you need to be very careful. Listen, I'll give you the hint. Here, for y, I put the subscript n. Means if I put n is equal to 1, I'm getting the first bright spot from the center. If I put n is equal to 2, I'm getting the second bright spot from the center. Means this subscript n has something to tell us in terms of the number of the bright spots. Right? If that is a scenario, here, what is the subscript I'm supposed to put here, and what is the subscript I need to put here? Is what we need to think of. Suppose I cannot put n here. In both the cases, I cannot put the same subscript. Let's see why. Suppose I put n here. Okay. Then if I put n is equal to 1, what do I get? In this expression, if I put n is equal to 1, I'll get 3 lambda d divided by 2d. But what is that we are missing? We know that the central spot is a bright spot. After that, where is the first bright spot? At a distance of lambda d by lambda into capital D divided by small d. So in between them, logically we can say it should be a dark spot. But if I put n is equal to 1 here, then what am I missing? I am never getting the answer for lambda into capital D divided by d. Am I clear? So I should not put n here. We'll think of what we are supposed to do. Okay. In a similar way, if I put n here, then if I put n is equal to 1, then what will I get? 2 minus 1. So lambda into capital D divided by 2d. So that is giving me the first dark spot. So here, subscript of n makes sense. Am I right? Are you able to understand? So here it makes sense because the number that you put here will give you the corresponding dark spot. If I put n is equal to 2, what will you get? 3 lambda. So see, 4 minus 1. So 3 lambda into capital D divided by 2d. Now think of it logically. Between lambda d by d and 2 lambda d by d, what is going to be the midpoint? 3 by 2. So 3 times lambda capital D by 2d. So that is giving me the second dark spot. So first dark spot is at lambda d by 2d. Second one is at 3 lambda d by 2d. So I'm getting the corresponding numbers. I hope it makes sense. So here, me putting a subscript n makes sense because it gives the corresponding dark spot. So for me to get the same corresponding dark spot here, what is the modification I need to do with n? I should not put n is equal to 1. Rather, I will put y is equal to n plus 1. Think of it. One minute, I'll complete that, then you ask. If I put n is equal to 0 here, then what will the subscript become? It will become y1. So y1 says that I'm trying to talk about the first dark spot. So when I put n is equal to 0 here, so it will give lambda into capital D divided by 2d. Makes sense? Right. So I'll tell you why I was stressing on this point much. Because some books give this equation and some books give this equation. If you follow them without a logic, you will confuse yourself. Because I'll tell you how the problem will be. Let's say they will say from the center, there is a point P where they are using 2 wavelengths. So you are able to understand that this distance, logically are you accepting the fact that it depends on the wavelength? Right. Means if I change the colors, wavelength will change. As a result of which, the distance will also change. Are you in acceptance with it? Right? They will say they will use 2 colors. Let's say they are using red color and blue color, for instance. Okay. When they are using red light at some point P, they are getting a bright spot. Let's say they will say they are getting the 5th bright spot. At the same point P, when they use green light, they are getting the 9th dark spot. So what is the distance? So bright spot, you have no problem at all because there is only one equation. Whereas when you talk about dark spot, where will you get confused? You will not know which one to use. So if they say 9th dark spot, for example, if at all you want to use this formula, then what will you write the subscript as? You will write y9 and you will substitute 9 here. Whereas if you use this formula, right, if you substitute 2n plus 1 and you take and substitute 9 there, you will get a wrong answer. What are you supposed to substitute there? You need to substitute 8. Is that clear? It is then you will get the same result in both the scenarios. So this is how problems are framed, and I'm stressing again, this is the place where I've seen people making mistake. So get it registered properly.
Sir, the substitution for the fields has to be negative.
Do it.
We get wrong.
Right.
So if we substitute -1, then we get -3.
Minus 3 lambda by 8.
So this is
Okay, what about that thing? That gives correct answer. How? You substitute n is equal to -1. Left hand will become y not. So you have to understand. So what you need to do in this scenario is, here n can only take natural numbers. So the symmetric part you need to just add a minus. Because everything I derived with respect to the upward direction. Are you able to understand? So if at all you want to find something symmetrical with respect to the origin, first find the positive value and then put a minus. That's it. So generally it will not be a scenario where the 5th bright spot in the top portion will coincide with the 9th dark spot in the bottom portion. So if you're taking bottom, it will be bottom only. So add a minus sign in both the scenarios. That's it. Okay. So make a note of this. So from where are you supposed to write? Second slide. So you done with this slide? Electricity. Market is important and then Huh? Supposed to solve problem, but this time is there. Let's see if there is any problem. So this is one of the problems based on interference. So we discussed. Nine. So this is one of the So this is one of the problems based on interference of light. So it says two plane monochromatic waves propagating in the same direction. We know that for interference, same direction is needed. So those two plane monochromatic waves are traveling with amplitudes A and 2A respectively. And the phase difference between them is pi by 3. Now these two waves are superposing. Calculate the amplitude of resultant wave. Simple form. So A is equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. So this would be root of A1 square is A square, A2 square is 4A square plus 2 into A into 2A into cos pi by 3. So this will be equal to root of A square plus 5A square plus 5A square into cos pi by 3 is R. And this is going to give us root of 6A square plus 5A square by 2. No, I'm sorry, it is 4A square. Become 5A square plus 5A square by 7A. Root 7 R. Oh, this is 4A square. Give me 2. So it will be 2. So it is root 7A square or root 7 times A. Okay. Proceeding to the next one. Listen. Two sources of intensity I and 4I. Okay. Two sources of intensity I and 4I are used in an interference experiment. Find the intensity at the points where the waves from the two sources superpose with a phase difference of 0, pi by 2 and pi. So if the phase difference is 0, what is going to be the wave intensity there? So I is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. If phi is 0, it will be I plus 4I, which will give us pi by. Right? Similarly, if the phase difference is pi by 2, then I will be equal to wait. So I plus 4I plus 2 into root of I into 4I into cos 0. So this will be equal to pi by plus 4I. So it will be 9I. Right. So here phi will be equal to, when it is pi by 2, you take this and substitute it here, I will be equal to, or I will call it as I dash. It will be I plus 4I because cos pi by 2 is going to be a 0. So I plus 4I, which is going to give you pi by. And when phi is equal to pi, then I dash will be equal to I plus 4I plus 2 into root of I into 2I into cos pi. So this will be 5I minus 5i minus 4i, it is going to be I itself.
Because we said four.
So 5i minus 4i is going to be I. Here. So these are all simple only, but X double slit are slightly, you need to know the concept. So I hope the concept was clear. So we'll do some more problems in the next class, and then we'll go to the last concept of this chapter, diffraction. With that, this chapter is over. After this chapter, maximum 6 classes or 8 classes, that's it, we are done with this syllabus. Means 2 more weeks after that. Okay. So start preparing. And you have any doubts, reach out. Otherwise, we'll wind up.
Yes, sir. Thank you, sir.